So now that we know what an array is, I'm going to move on now to creating a sort routine. And the plan is I'll have 10 numbers, all the numbers between 1 and 10, but in a random order, displayed. Then have a number sorted so that they're displayed then in ascending order. So that's the output I'm looking for. Now I've achieved this here by making some changes already. So I've taken our array A numbers and I'm initializing it with the 10 unique numbers between 1 and 10, and I'm displaying them here using this for loop, and I'm also displaying them there. This line here, you'll remember, is just giving me a couple of returns. But what I have done is I've made use of the built-in array sort method, which you can use just by invoking array.sort. Inside brackets you tell it which array you want to sort. So we're not going to use that because we want to code the actual sort routine yourself, and we're going to use that using what's called a bubble sort. So I'll take that out because that's where we're going to put in our own code. Run it again so that you can see that there's no change here. So we're going to do a bubble sort, and a bubble sort consists of comparing pairs of numbers. So from the top one, I would compare 10 with 3, and if 10 is greater than the 3, I would swap them around. So my numbers then would be 3, 10, 7, 2, and so on. So I would be then comparing the 10 with the 7. They would swap, then the 10 with the 2, until we get to the end. So if you work that out, you would see that we have 9 comparisons to do. So 10 with 3, 10 with 7, 10 with 2, 10 with 9, right down the end. So the number of comparisons that you need to do is actually whatever number of values you have minus 1. So that's the first thing we want to do. So we have 9 comparisons to do. So I'll start with a for loop, right, that's going to iterate 9 times. And inside that for loop, I'm going to say if our array called numbers, I forgot my brackets, so inside brackets, if my array called numbers at location I, which to begin with is going to be 0, if that is greater than the value at array position, so again array numbers position I plus 1, so if that one's greater than that one, I wanted to do something. What am I going to get it to do? Well, I want it to do the swap. Now what's important to know that is, as a human, we could take the first 2 numbers, like the 10 and the 3, and if I was writing them down, I would write them down in the correct order. But a computer will only do exactly as instructed. So if I make numbers I equal to numbers I plus 1, I can't then go and make numbers I plus 1 equal to numbers I, because it's now been overwritten. So what I would need is some kind of temporary value or temporary memory location to temporarily store what's currently in numbers location I. So just up where I've created the array, I'll create another integer called, just call it temp. Just give it the default value 0. So in here now where I want to do a swap, the first thing I'll do, I'll say temp is equal to a underscore numbers at location I, and then a underscore numbers at location I is equal to a underscore numbers at location I plus 1. Now I can take whatever's at location a numbers, okay, IE plus 1, and set that equal to whatever's in temp. So if you take these numbers, we had a 10 from up here, we have a 10 and a 3 to begin with. Is 10 greater than a 3? Yes, it is. So we store the 10 into that value temp. Then this location becomes equal to what that location is, so it becomes equal to 3. Then that location, which is still a 3, becomes equal to whatever temp is, which is now the 10. So that has the effect of swapping the first two numbers, and because we're going to get around 9 times, it's then going to have a check. So we've checked the first number against the second, then we'll be checking the second against the third, and so on. And what we should get at that stage there is that the highest number, the 10 in this case, should have floated, as I said, to the bottom. Because each test, the 10 is going to be bigger than anything it comes across, so it will ultimately end up at the bottom. So that was called a pass. And if I wanted to make a pass or have them all sorted, I would need to have a pass, another pass, and another pass to make sure they are all sorted. So in total I might have 9 passes altogether. 9 passes, each with 9 comparisons on them. So if I wrap this whole for loop inside another for loop, so if I said for, and this time I'll just use x as a variable because we're using IE and we're going to be in the same scope. So if I says for int x is equal to 0, and basically keep going while x is less than 9, and each time add 1 onto x. Okay, open my brace, but I'll close it down here. So 9 times, 9 times. So if I run that, click on the array, you can see there's the numbers in random order, and here they are here now in sorted order. Now, while this program does what we asked it to do, it's a very inefficient program, and let me just show you why. So essentially for our 10 numbers, we're doing 81 tests. The code execution has gone in here 81 times. So we're doing 81 comparisons where we don't necessarily need to do 81 comparisons. Let me prove that. So I'll create another integer, pardon me, which I'll call loops and give it the value 0. Inside here, I'll take that variable loops and add 1 onto it each time, and at the very end, just where I'm outputting, well actually I do it after this one here, I'll do, let me get a couple of blank lines just like this one here. Okay, so a couple of blank lines, and I will print out the value of loops. So it's loops dot toString. So if I run that, click on array, so you can see the unsorted array, the sorted array, and there we are taking up 81 different comparisons, which is completely inefficient. Computers are very fast nowadays, so it might look okay. But we'll leave it at that, and in the next lesson we'll look at a couple of methods of tidying this code up a bit to make it more efficient.